Good evening, everyone. This is Dr. Jignasha Thomar, and I'm here today to discuss the topic which has fascinated the academicians as well as researchers. Imagine a tiny engineered sphere, which is smaller than that of virus, and it is delivering some of the life-saving drugs to your body, of course, which is the targeted one. Or imagine a solar cell that is capturing the energy from sun with great efficiency. What comes to your mind? Yes, we are talking about the science which is at the verge of, we can say that progress and progress. So that is nanotechnology. So today I'm here to present my presentation. I'm here to give my presentation on tools and techniques that are used in the nanoscience research. So with this, I'm sharing my PowerPoint presentation here. Just a second, it is being loaded. Yeah. So this is the topic which I'm going to cover, of course, not in much detail. So let's see, first of all, what exactly nanotechnology is. So nanotechnology is the manipulation, we can say that it is a manipulation of matter at the level of atoms, molecules, or supramolecular level also. So by manipulating them, we generate or we create the material, we generate the systems which are having some new properties and some unique functions. The the American physicist Richard Feynman, he introduced us to the world of nanotechnology in the year of 1959. He delivered a very famous lecture, a talk on there is plenty of room at the bottom. And because of his vision only, nowadays we are preparing the nanoparticles which are formed or which are generally the silver nanoparticles, the titanium, aluminium, gold, silicon nanoparticles, and we can use them to create carbon nanotubes, nanowires, liposomes, nanoboards, quantum dots, and lot of a variety of the nanomaterial. And these nanomaterials are finding their applications in a variety of the fields. The one which I just mentioned is the drug delivery. We can use them in textile industry, electrical industry, biotechnology, and whatnot. And I would say that new and new applications are being developed these days to explore this science more and more. So the topic which I have selected is the techniques for the characterization of nanoparticles. Of course, there are a lot of techniques which we use to study the nanoparticles with different dimensions. But I would be discussing the technique which is used for physical characterization of the nanomaterial. Of course, we can characterize them for in terms of the electrical and magnetic properties as well. So physical properties of nanomaterial, which includes mainly size, shape, crystallinity, surface properties, these can be studied by implementing some of the general characterization methods like the spectroscopic methods, the one which are traditionally being used, UV visible, we can have X-ray diffraction, we can have dynamic light scattering spectroscopy. And in addition to this, we can have some of the traditionally known methods, imaging methods, say for example, like we can have transmission electron microscopy, scanning tunneling, we can have atomic force microscopy. Atomic force microscopy is actually the one with the help of which the nanomaterial was observed for the first time. So these are various methods. Let me introduce you with transmission electron microscopy and how it can be helpful for the characterization of nanomaterial or nanoparticles. So transmission electron microscopy, it generally gives us the idea about the morphology of nanoparticle, let's say size, shape, the crystal structure. And in addition to that, we can also use it to know the elemental composition of the nanoparticle or nanomaterial as well. This is the traditional transmission electron microscope where we use the electron gun to generate the beam of electrons, which is focused on the copper grid sample holder on which a very thin sample is loaded. So the sample, it interacts with the electron beam by diffraction, and the level of diffraction, the intensity of the diffraction, it depends on the orientation of the plan of atoms in the crystal, which will be directly relative to the electron beam. Now, this leads to formation of a high contrast image. and it is formed by blocking the deflected electrons. We can record this image and it can be analyzed further. This image can be analyzed or it can be used to get the idea about the internal atomic structure as well as the internal the structure of the nanomaterial, as well as it can be used to know the property of the atoms which are there in the material, as well as you can get some idea about the defects also. But at the same time, transmission electron microscopy is a relatively slow method. Slow in the sense that it takes a lot of time to prepare the sample, because we have to prepare a very thin sample, and the method is also being carried out under the vacuum. So this is the limitation of the method, but it gives very good resolution. As you can see here, these are the TEM, the high resolution of TEM images of nanoparticles like that of gold, that of silver, that of silica, that of silver nanoparticles. And the pictures are clearly depicting that the method is very useful to know the size, the shape, the arrangement, or the defects, if any, to know the defects, if any. So, transmission electron microscopy is a very basic and primary tool to know the physical properties of nanoparticles. And as I mentioned, there are many other methods, but we are discussing only this one today. Maybe in the next session, we will discuss the other methods or other techniques as well. So thank you very much, audience, to listening me with patience and interest. Thank you.